Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our lesson for 4.2.3. This is where we learn about unit rate officially and put our unit rate into equations that can be used to solve proportions or problems that involve proportional relationships. So before we get started, we want to make sure that we understand the terminology that we're talking about here. And first off, a rate, understanding what we mean by rate. A rate is a ratio, a comparison of two numbers or two quantities. But in this case, we're focusing on quantities that have two different units of measurement. So 14 miles in 2 hours. The ratio is a 14 to 2 ratio, but we are talking about specific units of measurement where we're talking about miles and hours. So the rate is going to be a number of miles per hour once we eventually get to a unit rate. Or you could have where you have cups, 3 cups in 2 batches. So how many cups would be each batch? That, once again, is the unit rate. So let's go ahead and get to the unit rate. The unit rate is a rate in which one of the units of measurement is reduced to a single unit, or 1. So if I take these 2 examples, let's start with 14 miles in 2 hours. If I want to express that as a unit rate, I can set up the proportion where 14 out of 2 is equivalent to something out of 1. And what we notice here is this: when you set it up for a unit rate, you're always going to take this number and divide it by itself to get this number here, to get the number 1. Anytime you divide a number by itself, you always get 1 for an answer. So because of the whole giant 1 process, if we're going to divide this by 2, we have to divide the 14 by 2, which essentially is just this problem right there. So a fraction is a division problem. So anytime you're finding the unit rate, you just take the 2 numbers in the ratio and you do a division. 14 divided by 2 is 7. So that means that the unit rate is going to be 7 miles per hour. Here, if we want to figure out how many cups per batch, we're going to have to change it from 3 cups in 2 batches to a certain number of cups in 1 batch. Same exact idea. We're going to have to divide both the top and the bottom number in these ratios by 2. And so essentially what that becomes is 3 divided by 2 ends up being 1.5. So we'll just say that the unit rate is 1.5 cups, or 1.5 cups per batch. Now, we have to identify, or it's helpful at least to identify, that these situations are proportional in nature. So let's continue with looking through problems and identifying how and why, or whether and why these situations are proportional. So proportional relationships can be identified in both tables and graphs. Today, we will have an opportunity to look closer at how graphs and tables for proportional relationships can help you organize your work to find the missing value quickly and easily. All right, so let's start with this. Robert's new hybrid car has a gas tank that holds 12 gallons of gas. When the tank is full, he can drive it for 420 miles before it is empty. So assume that his car uses gas at a steady rate. But we know this doesn't actually happen. When you speed up, you use more gas. When you drive at a constant rate of speed on the highway, you tend to use less gas. But in essence, what we're doing is our constant or steady rate of gas usage turns into an average usage. Okay, so we just have to accept that. It's more like an average, but that's kind of how we find those constant rates in a lot of these problems anyway. So the question is this relationship proportional? The relationship between the number of gallons of gas used and the number of miles that can be driven. Is that proportional? Well, a couple things. First off, if we're using at a steady rate or a constant rate, that's the first thing. There's like this constant multiplier. What is the number of miles per gallon that it would drive, right? And so there's your constant or steady rate. And 0, 0 apply in this situation? And in fact, it does. If you don't drive anywhere, you're not going to use any gas. So 0, 0 applies, and there's a constant growth rate. So that means, yes, this is a proportional situation, and we can solve it using proportional strategies. Now, the second question says, does the amount of miles per gallon change like Sonia's birdseed prediction, which was proportional, or like Gustavo's college savings? And in this case, it would be more in line with Sonia's birdseed prediction. So what I'd like for you to do is, based on this information that has been provided and the fact that we, just using our prior knowledge, understand that 0, 0 applies here, let's go ahead and copy down this table and fill in blanks. How much would it be for 6 gallons of gas? How far would Robert be able to drive his car? And then for 3 gallons of gas, how far would he be able to go on 3 gallons? Okay. Go ahead and pause. I'll pause, and you can finish this table, figure this out. Okay, so there are going to be a couple of different processes that we could use here. The one that we've used so far has been using proportional reasoning. So if we know that the car can go 420 miles in 12 gallons, how far would it be able to go in 3 gallons? And you look at that and you say, okay, can I find a giant 1 here? We could divide 12 by 4 to give us 3, so we would have to divide, that's a horrible looking parentheses, by the way. We would have to divide 420 by 4 to get our answer for this one. And we could do the same thing here, where instead of dividing by 4, if we divided by a giant 1 of 2, right? 12 divided by 2 is 6, so 420 divided by 2 will tell us the number of miles driven with 6 gallons. We could also find the unit rate. So if you wanted to find the unit rate, you'd figure out how many miles per gallon that we would go. And so that would involve us taking 420 divided by 12, and that would become our unit rate. Okay, so let me come back over here and let me show you yet another strategy. And I will use my calculator to prove that this works. Remember, when we decided a situation was proportional, then you could double or triple values, right? If you double 3 to get 6, you double the number of miles here, and that would tell you the number of miles here. Well, it goes the same direction, or it goes the same thing going in the other direction, where you're taking like half or a fourth. So what is half of 12? It's 6. So if we take half of 420, shouldn't we get the number of miles driven on 6 gallons, which would be 210. So I'm going to come over here and I'm going to prove that. I'm going to take my calculator. I'm going to say 420 divided by 2 does give us 210. And then if you take 210 and you take half of it, that should give us the number of miles driven for 3 gallons of gas, which is 105 miles. And if I come up here and I take 420 divided by 4, does my answer end up being the same? And it does. So once you realize things are proportional, if you can find the one that, if you can find one of these, you can double it and get more information, double that, get more information. Or you can use proportional reasoning, or we could use a unit rate. So let's go to the unit rate. What is 420 divided by 12? 420 divided by 12 is equal to 35. So that means that the unit rate for this situation is 35 miles to the gallon. So we could actually set up a rule for this situation where X represents the number of gallons and Y would be the total number of miles. So I could go ahead and say, all right, well, this will be our X, this will be our Y. So when X is 1 gallon would go 35 miles. 2 gallons would be 70. 3 would be 105. 6 would be 210. 10 of them would be 350. And it turns out 12 times 35, let's just go ahead and prove it. 12 times 35, stop it, times 35 equals 420. Well, what is 6 times 35? It's 210. So you can use a unit rate. You can set up a table and figure it out this way. You can use proportional reasoning and look for giant ones, or what we didn't do is we could have done cross multiplication as well. There are a lot of different strategies that you can use, and you just decide which one works best for you. All right, let's take a look at the Jelly Bean Company. They sell yogurt. Jelly Bean owns a frozen yogurt shop at Hearst. Oh no, that's a person. That's a person. Jill E. Bean owns the local frozen yogurt shop. At her store, customers serve themselves a bowl of frozen yogurt and top it with chocolate chips, frozen raspberries, and any other different treats available. Customers must then weigh their creations and are charged by the weights of their bowls. Well, she charges $32 for 5 pounds of dessert. But not many people want to buy that much frozen dessert. And I'm thinking, why on earth are you selling it at $32 for 5 pounds? Who's going to buy 5 pounds of dessert? So I'm just going to say maybe there's a little backstory where maybe they sell frozen yogurt to restaurants and they sell them by the pound because they buy them in bulk. But now they're starting to open up and sell them to individuals who may only want like a half a pound or a quarter of a pound, only a few ounces. So we need to figure out a unit rate that's a little bit more customer friendly for people just walking in and getting a small bowl. So she needs to help you figure out how much to charge her customers. She has customers that are young children who can only buy a small amount of yogurt, as well as large groups that come in and pay for everyone all together. So the first thing, is this proportional? Is it reasonable to assume that the weight of the yogurt is proportional to its cost? Does it seem reasonable that if you buy no yogurt, you would spend no money? Does 0 apply to this situation? Yes, it does. Does it seem like there should be like a unit rate, like a price per ounce, or price per pound? Yes, there does. So, because it's reasonable to assume that it's going to be sold by the ounce or pound and 0 applies, we will say that this is proportional, so we can use our proportion strategies. So, let's start with the table. Assuming it is proportional, make a table that lists the price for at least 10 different weights of yogurt. Did I include 10 here? 1, 2, 3, 4, 5. Yes, I did. Be sure to include 3 weights that are not whole numbers. So I did the half, the 1.5, and the 2.5. Okay? So what I would like for you to do is I would like for you to start with the information that we know. We know that this yogurt is $32 for 5 pounds. And what you should do is decide probably, maybe let's just go ahead and figure out what the unit rate would be. So the unit rate is going to be the price for 1 pound. So remember how when you have the unit rate, you just divide these two numbers. So take a calculator or take a little time to figure out what is 32 divided by 5. Once you figure out what that is, you're going to write this answer in here. And then you can use that answer to figure out this number and this number. And then you can figure out what these two are based on that number. And then you can go and work your way around. So see how if you can easily maneuver around this and fill those in and pause for a little bit. And then I will go ahead and fill those in the order that makes sense to me. Okay. So go ahead and figure that information out and complete that table. Alrighty. So first off, let's figure out what 32 divided by 5 is. 32 divided by 5 is equal to 6.4. Okay. So with that information, we know that, hold on, what am I doing here? What am I doing? I'm going to do that. I'm going to do this. We know that X is going to be equal to $6.40 per pound. So that's the unit rate. So I'm going to write $6.40 in here. If I double that, that's $12.80. If I double that, that's going to be $25.60. If I take half of $6.40, that's going to be $3.20. And if I triple this, right, 3 times 1/2 is 1.5, right? If I triple that, that's going to be $9.60. And if I double this, that would be 3, which we don't have the 3 on here doing. So I'm not even going to worry about doubling that. Okay, so let's go ahead and well, let's leave it at that for now. Now let's go to the 5. If I take half of 5, that's 2.5, correct? So if I take 2.5, which is half of 5, then the dollar amount should be half of 32, which is $16. If I double the 5, I get 10, so 32 times 10 is 64, and I double the 10 to get 20. 64 times 2 is 128. Now, hold on for a second. Let me just look ahead. Are we going to start talking about, yes, unit rate here. So what is the unit rate that we said for this particular situation? The unit rate is $6.40 per pound. So if I use this as my equation, y equals $6.40 times x, where x represents the number of pounds and y is going to represent the total cost, then I can check any of these using my unit rate. So $6.40. Which one shall I check? Shall I check let's check this one right here. So if I enter in 1.5, that should give me $9.60 if I've done everything correctly. So $6.40 times 1.5 is indeed $9.60. That's the answer that we got. So you can look and look for patterns in the table if you want to set up a table. But really, nothing is easier than finding a unit rate and then multiplying your unit rate times whatever your number of pounds is to find any price. And that's what they do at the store. So you're not always going to get like an even amount here. So what if you weighed your yogurt and everything came out to 0.79 pounds? Nobody is going to find that in their table. You just don't want to do that kind of estimating or calculating in your head. So you just take your unit rate, 6.4, times the weight, 0.79, and you get your answer. And so you'd round that up to $5.06 for that particular yogurt. That's how unit rate works. So if Jelly Bean decided to start charging 50 cents for each cup on top of the cost of the yogurt, would this still be considered proportional? Would you still be able to use this equation for that situation? And the answer is no. And honestly, I'd be a little offended if they started doing that, because they're not weighing the yogurt and then putting it into a cup. That's gross. They're putting it into the cup, so you're paying for the weight of the cup. You shouldn't be also paying an additional 50 cents for the cup. I'm going to write the manager. No, they're not going to do that, I'm sure of it. No, that wouldn't work. So that would change the equation to the price of the yogurt plus the cost of the cup on top of that. And if we were to then put that into the table, if we were to just add 50 cents to each, stop it. Okay, so if we were to add 50 cents onto each one of these, we would get a new price, and you would see that they would not be proportional. For instance, I'll just do this one right here. This yogurt would then cost $6.90. And if you double that, that would end up, what is that double? I don't want to do that in my head. 6 times 9, or 6.9 times 2 is 13.80, right? So if this was proportional, then the 2 pounds would be that price. But when you add 50 cents to 12.80, that's going to be $13.30, not $13.80. So by changing the nature of the situation, you change the nature of the equation where it's no longer proportional. So those tricks of doubling and using proportional reasoning will no longer work for a situation like this. All right, let's take a look at this. Lexi claims that she can send 14 text messages in 22 minutes. Her teammates, Kenny and Esther, are trying to predict how many text messages Lexi can send in 55 minutes. Okay, so is this proportional? If she spends no time texting, will she send any text messages? No. So 0, 0 absolutely applies. And can we assume that maybe she texts at a constant rate? It does say here if she keeps going at the same rate. So that implies a constant rate. So yes, we will call this proportional. So what I would like for you to do is use the information that is in this table. Kenny represented the situation using the table below. What do you think he's trying to do here? Why do you think he would find out what the amount of time it would take for 7 messages? Go ahead and formulate your thoughts, and let's go ahead and have you look at a few of these questions here so you can address all of these before you unpause. Okay, so Kenny represented this, explained his strategy. Then Esther wants to solve the problem using an equation. to write an equation to determine how many text messages Lexi could send in any number of minutes. In other words, figure out what the unit rate is and then put that into an equation like we did in the previous example with the yogurt. Then let's figure out what the answer is. What number goes in here for 55 minutes? How many text messages should that be? And then let's take Esther's equation and see if you don't get the exact same answer. Okay? So go ahead and take some time figuring that out. I will unpause shortly. You pause right now, otherwise you're going to see all the answers, and that would be cheating. Bye. All righty. Let's see how you did. First of all, what's the rationale for finding out the number of text messages in 11 minutes? Well, I believe that Kenny wanted numbers that were easier to work with proportionally. So if 14 out of 22 is equivalent to 7 out of 11, then we can use this to figure out how much it is out of 55, because you could just use the giant one, right? So what would 11, what do you multiply times 11 to give you 55? Multiply the same thing times 7. We know that would be times 5, right? So what does that answer have to be? We're looking at it being 35. So I'm actually jumping ahead. Find the missing value in Kenny's table. We think that missing value is going to be 35 messages. Okay? Now, Esther wants to solve the problem using an equation. So to use the equation, you've got to find the unit rate. So we'll want to set this up, and finding the unit rate in this case is a little bit tricky because you don't get a nice clean unit rate. You end up with a repeating decimal. When you do the division, first of all, what I did was cross multiplied. 22 times x is 22x, and 14 times 1 is 14, because I don't want to take, well, I guess you just have to do it anyway. 14 divided by 22 is going to give you technically 0.63 repeated, but I rounded it up to 0.64 messages per minute. So that means that the unit rate being 0.64, that's what we would multiply times x. Now, we have to be careful of this because I rounded up this unit rate. That means that our answer, when we multiply x times 0.64, 55 times 0.64, we're actually going to get something a little bit higher than 35 because we had to round this up. So let me just show you, when we solve the equation using this, we get 35.2 messages. That's the danger in rounding. However, if I were to do this and keep everything in the calculator, watch what happens. If I take 14 divided by 22, that's my answer as a repeating decimal. The calculator is thinking of these repeating decimals going all the way to infinity. Actually, I'm lying because look, they rounded it up in like the 20th spot. But at any rate, that's going to give us a really accurate answer if we leave that in as our multiplier. So now I'll just say that number, that repeating decimal, times 55, and this should actually give me the exact answer of 35. And it does. So, and whenever you round numbers that you're going to eventually use calculate, you're going to get a slightly wrong answer. There's no way around that. So, you know, we just have to be aware of the fact that some of these strategies work better for the perfect answer. Some of them have limitations. And unit rate can have limitations if you round the number, okay? But, you know, we're going to say that rounds to 35, so we'll say it's about 35 text messages. So what is the unit rate? Well, we could call the unit rate 0.63 repeated text per minute, or if you want to write it in fraction form, this would actually be exact. 7/11ths of a text per minute is the unit rate for this particular situation. All right, so let's remember, hey, why is that not there? Let's move you up. Okay, so this is the last thing we're going to do. We're going to find out what would be the unit rate for each one of these situations. And remember, whenever we found the unit rate, you could set up the ratios, right? $4.20 for 1/2 of a pound is going to be equal to something for 1 whole pound. You could use giant ones, or you just take this and you do the division. 4.2 divided by 1/2 would be the same as 0.2 divided by 0.5 pounds, since that's the same as 1/2. So now you can use your calculator to figure out what these unit rates are. So whenever you do the unit rates, you take this number, divide it by that number, and then you declare your answer as whatever the order was, the number of dollars per pound. Okay, in all of these, the first number in our rate is dollars, and the second number is pounds. So it's going to be dollars per pound. Okay, this is the last problem we're doing. Go ahead and work out all of those answers. Use your calculator, and then unpause when you're ready for the reveal. All right, let's see how we did. Did everyone see that this one was going to be $8.40? Sure. You know, you might have even looked for the giant one there. If you multiply this times 2, that gives you 1 pound. So this times 2 gives you $8.40. So it's $8.40 per pound. Not as easy to do it with these fractions. So how would we do that with the fraction? Would we just take $1.50 over 1 divided by 2/3 is the same as $1.50 over 1 times 3 over 2. So you end up with, that's a 2 there. You end up with $4.50, right? Because $1.50 times 3 is $4.50, and then you divide that by 2, and that ends up giving you the price of $2.25 per pound. Now, how would you do that on the calculator? This is what I would do. Oh no, how are you going to, I guess we can do it. We can do it. Let's do it. 2 divided by 3 is 0.6 repeated, right? But we would round that to 0.67, which is going to affect our accuracy. But watch what I can do here. I'm going to do the trick that the calculator does. I'm going to take $1.50, and then I'm going to divide it by 0.668, and I'm just going to keep going until the calculator won't let me do any more. We're done. Enter. We got the accurate answer. So there's your little trick. 3/4 is 0.75, so you could take 6 divided by 0.75 and get the correct answer. So that one would have been $8 per pound. And then we'll have to do the same thing there. Let's figure out what 5 divided by 6 is. 5 divided by 6 is 0.8 with the 3's repeating. So now I'm going to take $7.50 and divide it by 0.8 with only the 3 repeating all the way to the end. It won't go anymore. That should give me an accurate answer. The answer is 9. So this price is going to be $9 per pound. All right. So this idea of unit rate is used universally. When you go to the store, you want to figure out if you're getting a good deal on this box of cereal, you check the unit rates. How much is it per pound, or how much is it per ounce? When you go into the produce section, all of the produce is priced per pound or per ounce or per some unit of measurement. Those are all unit rates, and that's how you can compare the prices of different items that come in different sizes. One brand sells it at this price, another brand at another price. The cheaper one does not always end up being the better deal, because you might be getting a lot less in the cheaper product. So you check and compare unit rates, and this is how you find unit rates. It's a division process that is used when dealing with situations that are proportional in nature. All right, so let's move on to the next activity, and you are definitely going to have a check for understanding after this, because I want to see if you can do unit rates like this. Okay, take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling